Puff pastry is one of the most famous and delicious bakery products of all time. Its flaky, buttery texture melts in your mouth. But what really makes puff pastries? Puff pastries. Today we will dive deeper into the chemistry of puff pastry and the science of why it tastes so good. Before we go into the chemistry, let's provide some background information on puff pastries. Puff pastry is a baked good made from laminated dough, which is thin layered dough separated by butter or another type of fat. When the pastry goes into the oven, the water molecules in the fat vaporize as it expands the pastry as it puffs up. There are two distinct types of puff pastries, the Scotch or Blitz method and the English or French method. The Scotch Blitz method has fat in between the dough in small cubes, like this one here. The English French puff pastry have the fat layered horizontally and parallel to the dough, like this. In this model, we can think of the box as a layer of dough and the liquid as a fat, maybe butter in this case. When the puff pastry heats up, water molecules exit the fat and go up, which means that the departing water molecules is a gas. In this scenario, there will be a lid on top of the box, which represents another layer of dough between the fat and the previous layer of dough. You may be thinking, why doesn't the puff pastry rise indefinitely? In other words, why does the puff pastry stop rising? This is because of the condensation rate, which means that the water gas molecules go back into the fat. These two rates reach dynamic equilibrium, which is a phenomenon we studied in class, and the equilibrium is called vapor pressure. Vapor pressure of the pastry equals the rate of equilibrium between the condensing and evaporating water molecules of fat. The magic of puff pastry is all about the puff. Usually people wonder how it rises in the first place, because normally in order for the dough to rise like that, it would require yeast, baking soda, or baking powder. Puff pastry has none of them, but we now know due to the equilibrium between the condensation and evaporation rate, when it's placed in the oven, it is able to puff up and stay there due to vapor pressure. Now, on to our next topic. In order to make puff pastry or any other baked good, gluten is an important element. Gluten is made up of two types of proteins, gliadin and glutenin, which can be determined and divided by their solubility in aqueous alcohol solutions, gliadin being insoluble and glutenin being soluble. We'll focus on glutenin a little bit more today because it is the more important of the two in regards to its usefulness in food because it is an essential ingredient in the dough. Moreover, a new concept we studied in class, monomers and polymers, applies to this subject as well. Gliadins are monomers and glutenins are polymers. Another essential thing in making a baked good is flour, but each food requires a different flour with a specific percentage of gluten. In order to make puff pastry, you need to obtain bread flour because it is proven to have the best results making puff pastry and it has approximately 12 to 14% gluten. Step 1 is to gather materials, and we have 3 ingredients today: bread flour, an aqueous solution of water, vinegar, and salt, and finally our fat, which is butter. Step 2 is we have to mix the flour and the aqueous solution. Step 3 is we make the dough by adding the flour, a little bit of butter, and the solution into the mixer. Step 4. After a while of mixing, the flaky, powdery substance becomes more solid and gets closer to being the dough we use for the final pastry. Step 5. The dough is finished. Step 6. Before putting the dough in the fridge, we must cut an X through the dough to make sure that the dough doesn't get too glutinous, which makes the pastry stiff and hard. By cutting the dough, we cut the gluten strands in half and slow down the gluten's action and development, making a better pastry. Step 7. After putting an X through the dough, put the dough in the fridge to rest. Step 8. Prepare the fat. In this case, we'll be using butter. Step 9. Measure the right dimensions for the fat to be rolled. Step 10. Roll out the fat to the correct dimensions we just drew out in Step 9. Step 11. Take the dough out from the fridge and now roll the dough to the right dimensions. Step 12. Place the fat on 1/2 of the dough. Step 13. Fold the dough over. Step 14. Roll the dough and fat back out and perform something called a letter fold, which means you will divide the dough in 3 parts and the 2 outside parts will fold inwards, so you are to be left with the middle third. Do this rolling and folding process 3 times and roll it out one last time to get your completed fat and dough combination. Note, at this time the dough and the fat are very closely layered together, similar to the pictures we saw at the beginning of the video, but in this case, the layers of fat and dough are too close together that they aren't visible to the naked eye. This is no longer just fat or just dough. They are now layered together, although we can't see it. Step 17. Put small holes in the finished dough-fat combination so the whole thing rises evenly. Step 18. Put it in the oven and watch the puff pastry rise. Thanks for watching. I hope you learned a lot about the chemistry of puff pastries.